In this video, you will learn how to create awesome looking 8-bit fireworks using JavaScript and HTML. So let's get started. So starting from a blank slate using Visual Studio Code, I'm going to set up my HTML5 template. I'll give it a title 8-bit fireworks. And starting off, let's just add some style to the body to get things going. So background color, we're going to go with black for the sky for the fireworks. We're going to set margin and padding to 0 to get rid of those browser defaults so that we don't have scroll bars. And set height and width for our HTML body to 100%. So if we go ahead and save that and open with Live Server, we can see that those changes have been reflected. So next up, we're going to go ahead and set up our HTML, which is just going to be a simple canvas element. And at this point, we're just about ready to start scripting. So let's throw in a script tag there, and there's going to be two parts to these fireworks. First of all, the actual firework object that shoots up from the bottom of the screen, and then the sparks that are created when the firework actually explodes. So let's create two classes. We'll create a class spark, and give that a constructor, and let's create a class firework. And also give that a constructor. Now to kick things off, as usual, we're going to have our draw method. And we'll use window.requestAnimationFrame to call the draw method as often as possible, depending on how much performance and bandwidth the browser has. Okay, so at this point, there's nothing too exciting happening. One thing we can do right away is actually set up our canvas and get the context. So let's select that canvas element that we created with getElementById, and I gave it the ID of canvas. We're going to set the width and the height of the canvas to be the full screen because we want these fireworks to be and take up the full screen. So you can do that by actually setting canvas.width equals window.innerHeight. Sorry, inner width. I always mix that up when I'm saying this. Canvas.height equals window.innerHeight. Okay, and let's grab our canvas context. So that's canvas.getContext 2D. And the last bit of boilerplate we have to set up is going to be context.clearRect. So what this will do is just on every single draw, we will remove and erase everything that's currently drawn on the canvas. If we didn't do this, you'd have artifacts left over from the previous time that you drew to the canvas. Alright, so how do we actually get these fireworks popping up? Well, I like to use the math.random function to start generating objects at some sort of random interval. So math.random gives us a value between 0 and 1, and I'm going to say every time this draw function is called, if math.random is less than 0.01, let's create a new firework. So we're going to need a object to store our fireworks. So that can just be a simple array. And every time we end up in this if statement, we are going to push a new firework. Okay, so what sort of properties is this firework going to need? Well, it's obviously going to need a X position, a Y position. Could possibly give it a color, maybe define the size, how large of an explosion we want to have, and maybe the altitude at which we want the firework to explode. So in my constructor parameters, I'm going to give it XY. Let's call this one altitude, and color, and size. And then just set up the references on this object when it's instantiated. This x equals x, y equals y, that's the altitude equals altitude. This dot color equals color, and this dot size equals size. Okay, so now that we've defined those properties on the firework object, or sorry, the firework class, let's try and get something to actually appear on the screen. So we want to start initializing our firework with some values. So let's start out with the X value. To keep things simple for now, we can just say canvas.width divided by 2. So the firework will launch from the center of the screen. The height of the firework is actually going to be canvas.height because the Y values on the canvas increase as you go down the page. So we want to start at basically 0, which is canvas.height. It's a little bit backwards, but that's how it is. Next up, we want to define what altitude we want the firework to explode at. So again, keeping things simple, let's do const altitude is just going to be canvas.height divided by 2. So the firework will be set to explode in the middle of the screen to start. So we have canvas.height, altitude, color, let's just say blue for now, and size. So size we can define maybe in pixels, and we'll just give that, say, 500 pixels for now. So of course, just creating these objects isn't going to actually render anything on screen. We have to create our draw and update methods for the firework. So let's start off with draw and update. We'll just make those empty. And going back down to our main draw method, we are going to loop over all of the fireworks and actually draw them. And we can do the same for updates at the same time. Fireworks.forEach f.update. So now as we run through this draw method, we're actually going to start calling the class methods within Firework to make things happen. The one thing you might notice right off the bat is that we keep creating fireworks, but we're not removing them. And that will cause performance issues later on. So one little trick that I like to use for simple examples is actually to change this first for each when we're updating to a filter. And filter is going to return a new array of fireworks. So we can change our fireworks object to, our fireworks array to be defined with the let, which means that this is going to be up, which means that we can update this value without any problems. So the interesting thing here is that if update returns true, it means that we will keep the firework in this array. If it returns false, it'll be removed and it won't be drawn on the screen. So that'll be an easy way to kind of clean up the fireworks as we go. So right off the bat, we basically just want to move the firework from the bottom of the screen to the top, approaching its altitude. So we can do that by just updating the Y value of the firework and subtracting 5 each time, and that will cause it to move up the screen. In terms of what we're going to draw, we'll keep things simple again. So let's use context.fill style is white. And because I'm going to be changing colors quite a bit here, I'm actually going to pass in the context just so I don't have to fetch it within this method. And then let's draw just a rectangle for now, which will represent our firework shell going up in the air. So fill rect, this.x, this.y. I think at this point it'll be a good time to define our pixel size. So let's let pixel size equals, say, 10 pixels. So that will be the size of our firework shell and the sparks that come off of the firework, and changing this value will have some interesting effects. So we're drawing our firework, so pixel size, and I think this last one is going to also be pixel size, because this is our height and width of the rectangle. Alright, so the reason that we're not seeing anything at this point drawing on the screen is because our update function is just going to be returning null, because we're not really doing anything in there right now. So if we return true and save, we should start seeing fireworks popping up. Awesome, so there we go. We have randomly fireworks starting from the bottom of the screen and moving to the top. Alright, so at this point things should start getting a little more interesting. Let's actually try and start figuring out what is going to happen when the firework reaches its altitude. So let's declare a variable has reached altitude. When this .y, the y position of the firework, is less than or equal to this .altitude, we know the firework is ready to explode. So we can move our y adjustment into the else block and start looking to create some sparks within this top section here. So if the firework has reached its altitude and has not yet exploded, we want to create some sparks. So in order to capture that logic, I'm actually going to define one more variable on the firework. So this dot exploded at, we'll initialize this to null, but it's going to be a timestamp. So we'll actually know how long ago the firework exploded, and from that we can determine whether we should fade out the sparks or that kind of stuff. So if this firework has exploded, we're going to update each of the sparks. However, if it has not yet exploded, but it has reached altitude, we want to create the sparks. So I'm going to define another internal method actually called create sparks. And I'm just using the underscore there to define, kind of by convention, a private function, even though this still is public. This dot create sparks. Okay, so how are we going to create our sparks? Well, the first thing is we'll need to define what variables we want to pass into a spark for it to exist. Right off the bat, we're going to need our x and y position to track where to draw the spark. And we're also going to give this an angle. So what direction to move away from the explosion. And the last thing we'll do is set a max radius. So this will define how large the spark should expand before it stops expanding. So I'll quickly just define these class variables, this.y, this.x, this.angle, equals angle, this.max radius equals max radius. We'll also want to keep track of the current radius of the spark from the center. So we'll declare a variable radius, we'll initialize that to 0. So jumping back to the create sparks method, for each firework we want to know how many sparks we're going to create. So let's define a variable numSparks, and let's just initialize this to this.size for now. So if we're creating a 500 pixel firework, it's going to have 500 sparks. And this will probably change depending on what we see later on screen, because as the firework expands, as the firework size expands rather, it's going to go up by the square root since we're dealing with an area. However, this numSparks variable right now is going to increase linearly with size, so we might actually want to add less or more sparks depending on the size of the firework. So for let I equals 0, I is less than numSparks, I ++, we're going to loop over each spark and create it. So for each spark, let's start off with a random angle in radians. So if you remember, radians ranges from 0 to 2 pi, with 0 and 2 pi being basically 0 degrees angle. Math.random times 2.math.pi. So this will ensure that each one of our sparks shoots off in a random direction. The max radius we also want to be random. So we don't want all of the sparks having the exact same radius, otherwise we'll just be slowly moving out in a circle. So let's define max radius to be this dot size, but I'm going to use a little math trick here to actually increase the probability that the sparks will be near the outside, so we actually have more of a round shape. Because if I just did something like this dot size times math.random, our sparks might be all over the place and it might end up not looking like an overall sphere, which is what we want. So instead of math.random, I'm going to multiply the size of the firework by 1 minus math.power math.random squared. So what this will do is, if math.random returned 0.5, if we square that, it will return 0.25. So 1 minus 0.25 is closer to the outside radius of the sphere. So next up, we want to actually push the sparks that we're creating onto something, and that something is going to be our firework. So let's create an array of sparks on our firework, which we can store all of this. So this dot sparks dot push, and we're going to go ahead and create a new spark within that function call. So the spark is actually going to start at the current x position of the firework. It's going to start at the current altitude, because that's the altitude is going to be the starting point of the spark. And then we have our angle and max radius. All right, and on top of that, since we're creating these sparks, we can also set the exploded at time for the firework to a new date. Okay, so now that these sparks are actually being created, we are going to want to draw them. Let's go back to the draw method of our firework. So at this point, there's going to be two states for the firework, exploded and not exploded. So this dot exploded at, if that's defined, we know we have sparks and we should be drawing them. Otherwise, let's move this code back in here. So that will draw the shell as it's increasing in size. And if we are exploded, we want to draw our sparks. So before we draw each spark, let's set the fill style to the color of the firework that we have defined previously. And then we can just use a simple for each loop to draw each spark in the array. S.draw, and again we're going to pass through the context just so we can make some further modifications later down the road. Okay, so you'll notice that at this point our fireworks are moving up to the middle of the screen and disappearing, which is good because that means they are actually exploding. So let's hop over to the update method of our firework because we also need our sparks to update. So let's call this .sparks.forEach s.update. And this sets up well because now we can actually go define the behavior for the update and draw function as our sparks and hopefully get something appearing on screen. So let's define update. Let's define draw and start figuring out what we want to do here. So the update function should be pretty straightforward. So basically as time goes on, we want to move the spark further away from its origin. So we can do that by increasing its current radius, because the radius is determining how far away from the X and Y position we are currently at. So let's start off with something simple. So radius increase, let's do 5 pixels at a time. So this dot radius plus equals radius increase, and leave it at that for now. Now our draw method, so if I remember correctly, I passed in the context. Now in order to figure out how much to adjust our X and Y values of the sparks, starting with an angle and a radius, we actually have to use some good old grade school geometry and use the cos and sine functions to pull out the component for the X and Y from that angle and the radius. So math.cos, if we give it this dot angle, and then we multiply that by this dot radius, that will give us how far away we should move in the X direction. And similarly, we can do that for Y, except changing our cos to sine. And then we can go ahead and draw where this spark should end up on the screen. So this dot x plus dx. For our x value, this dot y plus dy. And then again, we're going to reuse pixel size for our width and pixel size for our height. Okay, so why are the sparks just expanding outwardly and not in the circle like that? It actually comes back to our radius increase. Right now, we're not actually taking into account the max radius and how far each spark should be expanding. in order to do that, we're actually going to play around with using the max radius as our increase rate. So if I start out with just increasing the radius by the max radius, that's not going to work out because immediately we're going to increase way too much, as you can see. So let's take the square root of that to slow things down a bit. Now that's a little bit better, but one thing I want to do here is as the spark approaches the edge of the circle, I want to slow it down. So in order to do that, I can actually use another multiplier here, which is basically going to look like this. So if I have this dot max radius minus this dot the current radius, and I divide that by the max radius to kind of get a ratio, what this will do is as the radius gets larger, this top value will approach 0 and the spark will stop expanding. So just like that. And because I don't want things to happen in a linear fashion, I'm actually going to wrap this in a power of 2. Or maybe even 3. Let's try 3 and see how that looks. Because we don't want things to slow down in a linear fashion, we always want things to slow down exponentially when dealing with recreating like real world stuff. So that's looking a lot better. You see that the initial expansion starts out pretty quickly, but then slows down as it approaches the outside. Now, pretty clearly the next thing we should actually tackle is how about getting rid of the firework once it's exploded. So to do that, I'm actually going to track the opacity of the firework. And in the update method of the firework, I'm going to reduce that opacity to 0. And then once it actually hits 0, we can remove the firework from the render. So let's start off by defining this dot opacity to be 0 for each of the fireworks. And then go into the update function and look to update the opacity within here. Okay, so the first thing we want to do is figure out how long it has been since that initial explosion. Because my thinking here is that maybe after 2 seconds, we can just automatically start fading out, and by that time, the firework will have kind of run its course. So let's see, say time since explosion. I always like to add a t in there for some reason. It's going to be new date minus this dot exploded at. So that will give us how many milliseconds have elapsed since we have exploded. And let's define another variable here called expansion duration. Let's set that to 2 seconds for now. So expansion duration is basically going to be the amount of time that we are allowing the sparks to expand before we start doing any sort of fade out. So if time since explosion is greater than or equal to the expansion duration, not export default, expansion duration, then we want to do some interesting stuff. So next let's figure out how long it's been since the expansion has finished. So const time since expansion complete, just making some really obvious variables here. That's going to be time since explosion minus expansion duration. Now, how long do we want the fade to last? Let's say fade duration will be 1 second. We can see how that looks in a minute. So if the time since expansion complete is less than or equal to the fade duration, we want to slowly start fading things out. Otherwise, if we have gone past the fade duration, we can set the opacity to 0. So how do we slowly reduce the opacity of the firework and the sparks? We can start with 1 minus some sort of ratio, and that ratio is going to be the time since the expansion is completed divided by fade duration. So you can see as this variable, time since expansion complete, approaches fade duration, this dot opacity is going to approach 0, which is what we want. Okay, so where is this opacity actually going to be used? Since the firework shell itself has already exploded and disappeared, it makes more sense to pass this into the draw method of each of the sparks, so that each of the sparks can have their own opacity set. So if we hop over to the draw method of the spark, we can say opacity, and right before we do the fill rectangle call in the context, we're going to do context.global alpha equals opacity, and save. Awesome. So now you can see after a couple seconds, once the firework has expanded, it eventually fades out. So I think at this point we can start moving away from the singular firework in the center of screen and make things a little bit more exciting by making the X position and the altitude and the color dynamic when the fireworks are created. So let's start by figuring out the color that the firework is going to be. So I'm just going to define a function get color. That took way long to type. I'm going to define a set of colors that I want to use. And I've actually predefined this already, so I'm just going to copy paste that and fix the indentation. And all this code will be linked in the description, so you don't have to try and watch the screen and figure out what I've done here. And then we want to return basically a random color from this array anytime the getColor function is called. So if I do return colors, we can do math.floor of math.random times the size of the color array. And that will basically return a value from 0 to, I guess, 7 or 8, depending on how many values I have here, and will give us our random color. So let's go ahead and change this blue to getColor and see if that worked. Perfect. So now we're seeing different colors. Let's randomize our X position. So instead of canvas.width divided by 2, we can multiply canvas.width times math.random. So now we have fireworks moving at different points in the screen, and we can do the same thing with altitude. Now you'll see in the code that I provide later, I do make a couple other tweaks to these functions to make sure they're not expanding too high or too low. But for now, we'll just keep it like this. So we have some variation. Now the next thing I'd like to point out is that right now, although we're drawing the sparks as pixels, they move very smoothly across the screen, which is not really how 8-bit screens work. Usually an 8-bit screen back in the day would only have maybe like 800 by 600 pixels. So in order to kind of recreate that effect, I'm going to define a new function. Call it p, which takes in some value. And this is actually going to make sure that depending on our pixel size, when we draw an x and y value to the screen, it automatically falls into a multiple of this pixel size. And you'll see the effect that that has in a second. So I can do that by multiplying pixel size by math.round. And then in there we'll have our input divided by pixel size. So for example, if I gave the value of 14 as a y value, this would round that down to 10. So 14 divided by 10 is 1.4. That rounds down to 1. Conversely, if the y value was 16, this would round up to 20. So if I save that, nothing will happen because we haven't actually started making use of our p function. So within our toDraw methods, we're going to wrap any code that renders something to the screen in that p function. So we'll do that for the spark, and next up we'll do that for the actual fireworks. If I save that, we should start seeing things move in a more 8-bit-ish pixelated way, which we do, which is great. Now before I close off, there's one more quick modification and one more thing that I want to show you briefly that we can do to make this a little bit more exciting. So in terms of the sparks, we can also set what I'm calling an opacity modifier so that not all the sparks are the same color, which kind of adds a bit more realism to this, I find. So if we define this opacity modifier to just math.random, and when we're setting our alpha value for the opacity, we simply include this opacity modifier, our fireworks will look more like they were in an actual 8-bit game. And that was more of my personal preference, but I kind of liked that touch. So with that, I will conclude this tutorial and make sure to check out the code that I provided. I'll provide two different samples, one that's a bit closer to what I've gone through here, and also a demo and the code behind the demo, which uses a few more advanced techniques to make this a bit more interactive and more exciting.